check. 1, 2, 3, 4. 1, 2, 3, 4. Check. Sound check. 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 1, 2, 3, 4. Check. Check. Sound. 1, 2. Everything's. Yeah. 1, 2, 3, 4. Okay.
Ja, wir werden einen IoT-Direktor haben.
1, 2, 3, 4. This one works too. Cool. This one here too.
Okay, so welcome to the core working group. I'm Carsten Burmann, this is Andrew McGregor. You have read all the drafts, you know about the IPR rules. Can someone close the door, please? Thank you. Blue sheets are moving around. We have scribes, we have a Jabber scribe, so we should be all okay. Please read this slide. If you cannot read it quickly enough, go to the webpage there. So we only have 3.5 hours this IETF, so we have a pretty full agenda, even though the slide looks relatively empty. It's actually relatively full because our slots are so short. So this is the agenda that was published. We are going to talk about two working group documents today about object security and about CNML. And then on Friday, we will talk about 2 other working group documents, COMI, and continue the object security discussion. The problem is that on Friday, everybody who's interested in security will be at the Crypto Forum Research Group. So we will have a little cozy discussion by people who are not interested in security about security. Okay, any changes, additions to this agenda? So consider it bashed. I want to give a quick introduction to the working group status. So actually, we recently reached the 6th year of our existence. I mean, the working group was conceived in 2009, and nearly 9 months later, it actually was chartered. And we have had approximately an RFC per year here. The last one isn't quite out of the process yet. So we started with Cullen Jennings and me, and in 2012 Andrew was nice enough to step in for Cullen because Cullen had been sucked in by the WebRTC vortex, and I think he hasn't seen the light of day yet. Oh, he is here.
My head's getting close to the surface someday. But I noticed you've done great since I left, up at RFC per year and nothing before I left. So, you know.
Okay, and I also can announce that the recharter process that somehow was drawing out over the last year has finally finished. Yesterday, The new charter has been approved. That hasn't been announced because it was a meeting here at the IETF, and usually the minutes are generated from normal telechat events. So it will take a while until this is formally announced, but the charter has been approved yesterday. Both our area directors are not going to be here today. So if we have any specific questions to the area directors, we will have to wait for Friday when Barry will be here. But maybe you want to say something at this point?
Sure. So, as Carsten said, it was 2012 when I stepped up as a chair of this working group. I'm now looking to step down because I haven't been able in recent months to give this the attention it deserves, and I can't see that changing in the foreseeable future. So we have, I believe, 2 or 3 people who would be vaguely interested or suitable to be a replacement chair. If anybody else is interested in that, please come talk to us. You know, I wish the work all the best of luck because it's a worthwhile project. It's simply that I'm being snowed under by other things. So, thank you all.
Yeah, and while we're talking about handing off the baton, I also would like to remind people that there will be a new working group, a new area director coming in tomorrow at the plenary. So today, the responsible area director is Barry Leiber, and from tomorrow it will be Alexei Melnikov. Here's a photo of Alexei, but you will not recognize him because he has a beard now, and there is no photo of him with a beard out there. So you have to ask people who is Alexei, and you will find him. So in the 6 years, we actually have had now 4 area directors who were guiding us, and Lisa did the best job because she chartered us. But before we were chartered, she actually stepped down as an area director, so she didn't have any trouble with us. And the images of the other area directors are kind of deceptive because it looks like they are smiling. Okay. As Hannes has pointed out, our milestones are a little bit in disarray, and we have to work on those milestones. That will probably happen with Alexei then. So just to remind people, this is, by the way, green, and this is yellow. VGA at work. So the block draft is in the IASG. It will be discussed on the 21st on the telechat. The mapping draft finished, working group last call. We will discuss this on Friday, what remaining work needs to be done there. And then we have a number of working group drafts, but maybe we should just jump into them. Now, one final announcement I want to make at the start. COAP can run on a number of very strange transports, and the most recent one, Tero Kivinen is defining a way to use 802.15.4 information elements for various IETF protocols. And one of the things we are looking at is just to run COAP over these information elements. So you can do something to an 802.15.4 node before it actually gets an IP address. So you might be able to configure it to apply management operations to it and control how it actually gets its IP address, and maybe even do some security things before it. Just mentioning this, the pointers here are the 2 drafts that are out there right now. But now we want to go to the current working group documents, and I'm already 20 seconds after schedule, so I have to hurry up. And the first one we will discuss is COAP over Reliable. Hannes?
Thanks, Carsten. Test, test.
Wow, okay, works.
So the co-op over TCP document, Simon can't be here, but maybe he's actually online. I have to check. So if you look at so I sent mails to the list about the open issues, and as the working group has the issue tracker, and we have entered all the known issues into the tracker so you can have a look at them. I think you also get the emails regularly sent whenever I make some changes, but just to keep a sort of a history of what's going on, this is just the JPEG to go to the issues, and I will do that a little later. But before I do that, when looking at the different items and trying to resolve them, there were two things stood out, and I would like to discuss them first before I go into some of the other issues. And my expectation is to, at the end of this session, to have your feedback and hopefully all of the issues solved, or at least a way forward so that we get the document closer to completion. So if you had a chance to attend the Yokohama ITF meeting, then you may remember that we had in an earlier version of the document, which is shown over here, the non-working group item, we had different alternatives of the encoding of the shim header included. There were three popular mechanisms described that people put forward. There were others, but those, as a summary, in case you don't remember, the option one was to have a 16-bit lens field, and the other two options, essentially with variations in encoding, suggested a variable lens encoding 8, 16, and 32-bit. We picked number one at that time based on your feedback. Then when 2 weeks ago, roughly, we had a meeting. There was the Thing-to-Thing research group meeting in Santa Clara attached to the IAB Semantic Interoperability workshop, and we had a chance to meet with the OIC people, OCF people now, and they told us that they had actually picked a different option, which is of course less ideal, because now we have essentially with the same URI scheme, two different implementations of this co-op over TCP functionality out there. And the reason why they had chosen a different encoding was simply because they were trying to use co-op over TCP to distribute firmware updates, which is not super surprising, but they had, and if you use, so obviously if you have a 16-bit lens field, what you can do is you can get a maximum length of 64 kilobyte, but we also have, as Carsten mentioned earlier during the status update, we also have the block option, so you could obviously go larger, with the side effect that because of the block-wise transfer sort of creates chunks that are of size 1 kilobyte, so you obviously do a lot of transfers. So when they tried to compare this, the different options in their implementations, they figured out that it takes, as I described in one of the emails that I also sent to the list, it takes, I think, 10 times as long to transfer the message. So of course we never, and specifically they looked at the transfer firmware updates not for these tiny microcontrollers, but more for devices that you would classify as these BeagleBones, running Linux type of devices. And there you have, they looked at the firmware update for 4 megabytes, if I remember correctly. And yeah, that's something we haven't considered. And so the question to the group is, should we revisit this discussion and or revisit this issue and figure out what we should do, or should we, for those cases where people actually want to deal with larger software downloads, we can obviously make the recommendations that they first should use a different protocol, let's say HTTP or HTTP2 in those cases, or they should just live with the slower firmware update because presumably it's not that frequent, and get over it. So it's a little bit of a tricky issue, and I'm curious what your whether you guys have an opinion about this.
Go 2 slides ahead.
Oh, say again. Okay.
Just to drive this point a little bit home. So in RFC 7252, we have decided that the usual maximum size for co-op messages is about a kilobyte plus a little bit space for headers. And this is what we expect to be able to handle in constrained devices. Even that may be a stretch for some constrained devices, but this is kind of the going currency for messages going back and forth between constrained devices. So this is what we are trying to do. And the L1 that we chose in Yokohama, that provides a framing mechanism for messages up to 64 kilobytes. So it provides way more space than what the base co-op specification recommends as the maximum message size. And just because I don't like artificial limitations, the approach L3 actually allowed 4 gigabyte as the maximum size of a message. And now the block protocol has a 1K maximum size. So the result of this is if you use the fact that larger messages can be sent over TCP up to the size that is allowed by the framing, then you run into the slightly perverse situation that when you go beyond 64K, you suddenly have to go to 1K lockstep communication. So that's the reason for this significant performance difference between L1 and L3. L1 sends you, when you do a 4 megabyte firmware upgrade, L1 sends you down to 1 kilobyte messages, while L3 allows you to send a 4 megabyte firmware update in one co-op message, which is not exactly the way we originally thought co-op would be used. So that's kind of the issue here. So it's not something that is in any way a surprising performance problem of co-op. It's just co-op is being used in a way that we didn't originally design it for. And I think that the question that we are trying to answer here is that something we should accommodate? Now, a little bit of the problem maybe can be taken away by saying if you want to do block transfer over reliable, we actually can help by extending the blockwise transfer protocol a little bit. And just to show how this can be done, I wrote a little draft which is called BERT, blockwise extension for reliable transport, and that essentially says for a block we might just reserve take the reserved code point 7 and say this is actually not a fixed size. It would be 2048 according to the logic of the block protocol, but instead we just use the amount of payload that happens to be in the message. And that works fine on a nicely sequence preserving, reliable transport. It's not something that you really would want to do over UDP, but it works over TCP. So this would be for reliable transfer only, for TCP, TLS, and WebSockets, and would allow you to use larger blocks. But of course, it would still be limited to the block size that the framing gives you. And of course, it's simpler to just say, okay, once we have TCP, we can essentially use any block size. Of course, we run into ugly head-of-line blocking and all that stuff, but maybe that's not a big problem. So if somebody wants to do a simple firmware upgrade mechanism that would be possible. And now back to the thing that we're trying to decide. Is that actually a reason to deviate from our decision, to reconsider our decision at Yokohama and say, okay, L1 16-bit, that's maybe not a good artificial limit we are putting in there. Let's go for 32-bit length, and actually there would be two obvious ways of doing that. Still doing L1 with a 32-bit size, that's also a possibility, or following what OCF has done. Now there is a certain incentive following what OCF has done, because we can save a lot of discussion with them about changing their specification and so on. Of course, it's a little bit about losing face as well and so on. But by just going to L3, we are making our life a little bit simpler. But the underlying question really is that actually something we want to accommodate? Is CoAP now a protocol where we expect message sizes of 4 megabytes to be standard currency?
Yeah, like, guys, wake up.
Since no one else is awake. So these devices generally use co-op for regular stuff, so I'm not sure if we can really ask them to use HTTP or HTTP2 for firmware updates. So I think we do need some way to accommodate that, whether it's just be happy with slower firmware updates or one of these. I don't have a good answer for that. I think if we have implementation and of all the options and then see what makes sense.
Well, we know we don't need to. Of course, we could implement all of them to just see how complicated it is and so on. But we have an implementation, or we have implementations of L1 and L3. The difference between L2 and L3 is minor. It's just a different type of packaging. Conceptually, it's not different. But I believe Carsten summarized the point quite correctly. Is whether, so like last time when we discussed it, we didn't, or at least I didn't envision that we would use it in that specific way, a co-op in that specific way, and of course firmware updates is a useful scenario, but we didn't look at what would happen if you distribute firmware updates of that size, and I think that's the difference, and I believe it's grounded in the way of what OCF works on, which is not only on these tiny microcontrollers, but more these A-class devices as well. And go ahead.
Akbar, I think it makes sense to align with OIC if possible, because they're obviously using it, and we're still early in our process. So I don't really see good advantage to not complying with their request.
Yeah, Alexander here. So running co-op over TCP, basically we are already saying, you know, we are not in a very specific radio technologies where we really need only UDP kind of stuff, and we are fighting for every bit out there. So if there are not any implementations out there that really depend right now on L1, which I think is not the case, I see no problem into moving to 32 bits. If it's so, yeah.
Thank you. Christian.
Christian Groves. I think the question was, do we see anyone using L3? And if OCF has selected that approach, then obviously there's needs for it. So I'd say we align with them. As being at that meeting, they did discuss why they went for that solution.
Ari Keranen, if I remember correctly, there were no really strong arguments either way once we were deciding between L1 and 2 and 3. And now someone has experience on this and chose otherwise. To me, it seems reasonable to follow that.
Okay. You want to do a hammer, or is that Emmanuel? Well, it was pretty clear. I don't know.
No, I don't want to do a hum. Oh, we have one more.
Matthias Kovac, Siemens. I just wanted to remind the decision why we took L1 was because we couldn't predict how this will affect the future if we actually want to use co-op as it was designed to, so with these small devices. So nobody so far has implemented actually the proxy that can translate between the UDP and TCP. In that way, how can we chop this up? What happens if we establish this kind of new class of co-op that now works with powerful Raspberry Pis and Ethernet, and basically, I don't know, is a fancier way of doing HTTP. So what does this imply for the new devices that should be part of the same ecosystem? Don't they have a chance then? Is this kind of another segregation again? I don't know if anyone actually thought about this, and because we couldn't answer this question, we said, or at least my opinion was, let's be conservative here and ensure that this will actually work for the small devices. And yeah, I mean, at the moment, this is the use case. We need this. Let's go for this. Maybe we should really think about what this means in the future if we have the small constrained devices in the same network, in the same ecosystem. Does it really work well together, or do we then have actually the same separation we have now with the big web and the constrained RESTful environments?
So what are you suggesting us to do? To look at the gateway implementation, see whether there are any hiccups?
I mean, yeah, exactly. So an educated decision, I think, is only possible if we actually put everything together. So we have this kind of gateways where the small device wants to talk to these big devices, also to the cloud services. And what happens there if there are a lot of devices that assume that megabytes aren't any problem? And more importantly, does it work to split it up in a nice way so that we have a gateway that receives a huge chunk of megabytes? Can it actually chunk it down to the small sizes we need for UDP?
Mm-hmm.
So I'm at that microphone now, Carsten Bormann. I think in protocol design, we often have split between something that could be called mechanism and something that could be called policy. And a classical mistake in designing a protocol is actually trying to encode policy and mechanism. And so the textbook example was when IPv6 was designed, we decided there have been so many accidents with IPv4 where people switched off the checksum. We're going to make the checksum mandatory. So the IPv6 checksum mechanism was designed to encode the policy that there always should be a checksum. And this decision has bitten us so incredibly often since it was taken. It's really a nice example why you shouldn't encode policy and mechanism. I think nobody is so far has made a proposal to discard section 4.6 of 7252, which says please use a message size of 1 kilobyte. So that section is not going away. The question really is, do we want to design this mechanism in such a way that it kind of encodes the policy that we want to have small packets forever? And yeah, my experience after a third of a century of protocol design is kind of, let's be very careful about doing that.
So do you want to do a hum so we can actually...
No, actually, what I would like to do is somebody in a previous meeting, I think it was COSI, the working group chair asked who would be willing to die on a hill for this battle? I mean, who really cannot live with a specific decision? So that's really, and he also added, you only can die once. Who really cannot live with reversing our Yokohama decision and going from L1 to L3? And who cannot live with sticking with L1? Okay, so it's kind of not a decision where life and death is depending on.
And the good thing is there are no hills in Buenos Aires anyway, so.
So,
So you won't die on that hill that doesn't exist. But
so to me it seems this is really a matter of taste. And huh? No. I think the majority of the people and the weight of the arguments, if I may weigh them, was for actually reverting our decision in Yokohama and moving to L3. As a working group chair who has to explain to people, hey, this is we did this different than you decided. Also, I wouldn't be unhappy about making this change now. I mean, it's ugly because we have told people we already have decided for L1, so they have to change their implementations again. That's a significant cost, but I think the overall sentiment here in the room has been for making that change. And of course, as always, we will verify this on the mailing list.
good. Issue 1. The other aspect is when looking through the review comments that Klaus provided, it was many of them hinted to the fact that the shim header itself, which we just talked about a second ago, is actually not entirely sufficient to cover some of those things. And in his review, Klaus pointed out a couple of things that I included the issue numbers here. He says, he asked a couple of questions, how do we convey error messages? So if there's something wrong with the lens encoding, which is not a problem of co-op, because at this level it's the lens of the shim header, how do we convey that error message back? How do we exchange keep alive messages at this level? And there were a couple of different ideas on how that could be done. Christian suggested ICE. I pointed out that there's someone pointed out that there's a TCP heartbeat mechanism optionally available. There's also the application layer keep alive messages. But of course it would be possible to do that keep alive also at this layer. And specifically, since there's a little bit of a mismatch between what TLS provides, or DTLS, and what is provided when you use co-op over TCP alone. The next thing is negotiation of or indication of co-op versions, or even the sort of indicating the name of the server you are contacting, which is sort of the equivalent concept of what you can find in transport layer security with server name indication. So if you have a hosting solution and you actually then indicate on that there's multiple domains are hosted behind a single IP address. So the question then that appeared to me, which I posted to the list and Carsten provided some further details, was should we actually extend the shim header functionality and the design sort of a small little bit of protocol machinery in there. And if you look at Carsten's message to the list, he indicated we could actually reuse some of the co-op functionality for that purpose already. Which did you say about anything about that?
So, yeah, well, one question is, do we want to add anything here? But assuming that the answer is yes, how do you do this? And one way, of course, is to say, oh, let's design a nice little protocol like the TLS handshake protocol that we run in front of the actual co-op message exchange, and then we can solve all the problems there. Now, my experience with protocol design, of course, is that protocols grow and grow and grow and grow, and in the end, this little additional protocol we have added to co-op is going to be as complicated as co-op itself. My idea was to say, well, we already have a nice protocol which is called co-op, and that gives us a way to send messages. So why don't we just use this mechanism to send signaling messages alongside the actual co-op messages? So we could have things like capabilities or settings messages, we could have ping and pong messages, we could have orderly release and abort messages might give diagnostic messages, and so on. So all this, of course, can be designed, but it's actually not necessary to extend the shim header for that, but we already have a nice message format, and we could be using that for this purpose. Now, of course, for each of these functionalities we could add, there should be a pretty high bar that we have to pass before we actually add it. So do we really need that? And I think we need to make those decisions for all these cases. But I think what we can do by using the signaling messaging mechanism is avoid designing another protocol here. But we can just use the existing messages. Of course, we add a little bit of state machine for the capability stuff. That's unavoidable if we really want to do version negotiation or capability negotiation. But in general, it will be a relatively inexpensive addition to a co-op over TCP implementation.
Yeah, the other possibility is to just say nobody ever uses co-op over TCP directly. They always use it with transport layer security, and transport layer security provides a number of those features already. Maybe not all of them, but for example, the server name indication, the heartbeat mechanism, as an example, these type of things.
And auto release. Yeah, so that would be a little bit throwing out the baby with the bathwater, because just because we cannot do some things over naked TCP doesn't mean that there is never a good use case for that. So but that would be one possible result of looking at all these functions and saying, okay, if you really want to do orderly release, use TLS that provides you an orderly release mechanism. So that would be one way of solving that particular problem. I personally wouldn't be unhappy with that, but we still might want to add a capability negotiation or an SNI equivalent mechanism to TCP, and this little approach here would give us an easy way to do that.
Okay, so now it's your turn. I assume that you understood what the issue now was, and what's your take on it? Like, of course, it introduces a little bit of complexity. We could reuse code, obviously, from co-op, which we about to shuffle on top of TCP. We would have to figure out like what features we exactly want. There's obviously this pre-populated list of what Klaus had been asking for, but it would probably be a starting point.
Let me just clarify one thing here. Klaus put these issues in not because he thinks we have to do all those things, but because he said we haven't been discussing whether we want to do this, and we should have the discussion. And if we deliberately decide we don't want to have them, Klaus will not be unhappy with that.
Yeah, I understand. So what's your take on that issue? I think it's a bigger change to the document, definitely. So if you are implementing co-op over TCP, that's probably something to be aware about. Christian.
Christian Groves. Perhaps one thing we might also like to think of is the use of co-op over foo, basically, because I could envisage that another one of the transports we have is WebRTC data channel, and that already has mechanisms for establishment and release and things like that. So what we design here, then we would probably need to look how that can be either reused or how it would be used in those environments.
Elio Domaggio from Microsoft. I think that we're implementing co-op over TCP. Actually, we do have an implementation of co-op over TLS, to be precise. We definitely feel the need of this kind of extra messages on top of TCPs, especially pings, and especially signaling error conditions before terminating connections. Those are things that are really, really needed for us right now.
Yeah. Yeah, after reading the review comments from Klaus, that also occurred as an oversight to me, that we hadn't maybe we paid too much attention on the different styles of shim header and forgot the rest. And yeah, so should we do a harm on that one? To either go for adding the signaling protocol, or people who have checked?
Yeah, I think we haven't really decided anything, because we still have to make the decisions on the specific items, and we are not going to manage to do that today.
No, but
it seems that the obvious direction forward is looking at these 4 items and see, do we want to have them? Yeah, I haven't seen another proposal for doing this, but of course we are open to new proposals. So signaling messages are not the only way to do this. So if somebody has a better proposal, that would be certainly something we want to hear. But I think the way forward is to check these items on the mailing list. Do we want to do them, and then add them to the document if we do.
Okay. Can we? Could we click to the issue tracker, or should I briefly go through the items?
We're already 7 minutes over schedule on this
okay.
item. So let me just point out that this issue 387 has been around for a long time, and it's kind of a color of a bike shed thing, but we have to make a decision here, and it would be really useful if you all were clicking through the issue tracker once, and if you have an idea on one of these things, whether it's useful or not, please send in a message to the mailing list. That will help us make the decisions.
Yeah, we just talked about a few of those. So we talked about the ping pong, sort of the keep alive mechanism. We talked about the version negotiation, the error handling with the connection close reason. We talked about the server name indication. We talked about layer 1 versus layer 3. That was the initial one. The topic that Carsten just mentioned was the issue number 387, which is the should ALBN, which is an application layer identifier and transport layer security, should that be sort of mandatory or not? Currently, the document says if you need it, use it, otherwise not, based on some out-of-band pre-configuration. And it's obviously, like in some, so it relies on some external mechanism to say whether you need that, whether there's multiple. So the problem is if you have a server running a couple of different applications all on board 443 or port 80, depending on how you configure your server, then you make the TLS connection there, but then you need to demultiplex it somehow, because there's no port information available, and so you need to pass it either to, for example, your HTTP S server, or you pass it to your co-op server, and this is an indication that that helps you to make that decision. Okay, yeah, I think I will keep it at that.
Okay, in that case, I have one final point here. We have a WebSockets draft that in some ways is identical to the TCP TLS draft, in some ways isn't. For a while it wasn't quite clear whether people understood what the use case here is. The use case is I have an application that is running on a browser and wants to talk to a co-op device, and of course I can invent all kinds of protocols for talking through my web service and sending things to the CoAP device and back. But maybe it's just easier to send the CoAP message over WebSockets. And people are doing that. So it's not a theoretical thing. It's actually something that is used in applications. The interface between the application running on the browser and the application running on the server is a local interface of the application. There is, strictly speaking, no need to ever standardize that. But of course, we want to encourage the reuse of software components. So it seems like a good idea to actually say how this should be done. And we can use two different drafts and keep them in sync, or we could just take the existing WebSockets draft and merge it on the TCP/TLS draft, probably put the WebSocket specific part into an appendix, and maybe use some of the text in there, which actually is useful for explaining some things in a bit more detail than the TCP/TLS draft provides right now. So my proposal would be to just ask the authors of the two drafts to work on this merge. This, of course, would mean that we move WebSockets from an individual draft to a working group document. So we would have to decide to do this and discuss it on the mailing list afterwards.
Okay, so moving forward, what I'm going to do is on the first issue about layer one, the option 1, option 3, I'm going to post a mail to the list to confirm that we revert our decision from Yokohama, switch to option 3. Then with regard to the signaling messages that we talked about, also message the list to sort of solicit alternatives or to confirm the decision to add those signaling message exchanges, and with maybe some details on how that actually looks like so people have a better idea. And then also a message on this specific issue on the WebSockets, whether the guys are okay with making that merge. Good. Okay.
Thank you. Next. Oh, Michael, are you out there? Michael is out there. Michael, can you press some button you would need to do a remote presentation? Michael, do you hear me? Mm-hmm. Oh, yeah. Perfect. Okay, so Michael, we don't have video of Michael, but we don't need video of Michael. Michael, say something? I did. And now you threw him away. Sorry, Michael, you have to re-queue. We weren't quite sure that the red button worked. Yes. Okay, so can you say something again? We don't hear you. So, Michael, maybe you can readjust your audio equipment, and we just change the sequence of the two items and go to object security now and go back to the resource directory when in 20 minutes. I have no idea. So let's just jump forward to the object security.
So I have 15 minutes or something like that, less maybe, since we are running late. Okay, hello everyone. This is a presentation about requirements for CoAP end-to-end security. And this is a new draft, which was announced, this cooperation was announced the last face-to-face meeting. It's a joint work with Klaus from University of Bremen, Ludwig from SIX, Francesca and myself from Ericsson. So this is not the first draft on end-to-end security for co-op, but to our knowledge it's the first attempt to make it a precise problem statement. And basically what we want to do with this is we think that end-to-end security for co-op is very important, and we would like to have a foundation for that when new features are introduced in co-op. So as we have seen, the current features can actually support end-to-end security, but when you add features like co-op over TCP or other new features, it's good if you have at the bottom of your, if you have some reference that allows you to make an analysis whether that feature also works with end-to-end security. Okay, so I apologize for making the font size the same as the Note well, so you probably won't be able to read anything of these slides, but I'll tell you what's on them. So there's a few slides telling you about the draft, and then I'm happy to have any comments on this, what you think, if it's useful, or if we're missing some fundamental parts. So the basic setting here is that co-op is using DTLS for security, and at the same time it relies on proxies for scalability and efficiency. And these proxies, in order to perform their task, they need to terminate DTLS, which means that the entire message is in clear and can be manipulated and read, and you can also inject messages, and none of that will be protected or detected by DTLS. And one way to mitigate this is that instead of using DTLS, which encrypts the entire message, you use some application layer security, which encrypts the selected parts of the message which the proxy doesn't need to handle, and only exposes those parts which the proxy needs to perform its function. So the setting is very simple. There is a client and a server and one or few intermediary nodes, which I call proxies, but they are not always proxies. It could be also, for example, in pub/sub brokers, which is covered in this document. And the proxy has a certain functionality, which is we need to define very carefully to make this analysis. So the proxy receives a message and it acts according to certain processing rules. For example, forwarding when the link is up, or only forwarding when it doesn't have a fresh response, or a broker would perform like forwarding all the new publications to subscribing clients. So the assumption we make in terms of security is that there is a security association between the endpoints. In the upper image, it's a client and an origin server, which have a security association. And in the lower, it's a publisher and subscriber, which has a security association. We don't assume any security association between the intermediate node and the endpoint. This doesn't mean that the intermediate node can't perform a security function. So for example, a forward proxy, a caching proxy, could, for example, save a lot of processing in the origin server by responding with fresh responses. This could be useful in an overload situation, and it will save the resources of the origin server. So the proxy would perform an availability service. But and the same case in the broker setting, the broker could verify publications before forwarding to the subscriber. And then again, if you don't trust the broker, then the subscriber would need to verify it anyway, but it might be relieved from verifying a lot of unnecessary or erroneous publications. So the method we used in this, yeah, sure. Go ahead.
This Akbar, could we go back to the previous slide, please? Just so I understand, if it's a forward proxy, though, doesn't it mean that the client knowingly sends it to the forward proxy, and then the forward proxy is going to knowingly send it to the origin server? So there should be, from what I understand, some sort of security association between the client and the forward proxy, at least, and most likely between the forward proxy and the origin server. I thought that's how it worked on HTTP as well.
So it doesn't have to be a security association, but you're right that the client would instruct the forward proxy to do something. That's right. And the origin server could verify that the proxy had performed that action. But it's not necessarily any security association with the forward proxy.
Okay, I agree. It's not necessarily, but it could be. It's not excluded either.
Sure, it could be, but so from the point of view of this draft, if you have a security association with the proxy, it's not an endpoint in this setting. Sorry, it's not an intermediary node. It's an endpoint. So what we look at is when you don't have a security association that with an intermediary node, that's the type of intermediary nodes we are looking at.
Okay.
Thomas, just to understand, you assume that the security association pre-exists,
yes.
right?
Yes.
Right. Have you thought about methods to establish the end-to-end security association?
Yes.
Oh, right, okay.
So that's for example the topic of ACE, the working group ACE, the authentication authorization.
Yeah.
Yeah.
No, but in co-op only, I was
sorry.
Limit the scope to co-op. Have you thought at solutions that could work with co-op only, not taking into consideration a trusted third party? That is there. Just negotiate from the end to the other end. Do you have a solution for that? Have you thought about the problem without the ACE framework in place?
Without sort of out of the box.
Yeah.
Yeah. I mean, generally in security, you need to start with something.
Yeah, exactly.
Yeah, and if you don't have anything to start with, I can't help you. But if you have something in the beginning,
something like a certificate, right?
For example, or a raw public key,
right?
So or a trust anchor.
A long time ago, we were proposing a connect method for co-op, and this could be used to go from client to the origin across proxies, right? Via and then use the DTLS. The DTLS initially to just create the key material and then export the key to the application layer and use the key that is negotiated this way to establish the end-to-end security association.
Okay. Maybe we should have a discussion offline. Okay. Thank you.
Last moment, Thomas, if you want to do that, the simplest way to do is just use DTLS over co-op. But that's not the reason I came here. So I think that this picture is really very crucial. It's showing two things and is kind of showing them in the same way, but they're quite different. In the first case, it's pretty clear what our objective is. Our objective is to protect the co-op exchange and make sure that the semantics of that co-op exchange is preserved, even if the forward proxy actually is an attacker. It's not really clear to me that we have the same situation in the lower picture because this is two co-op exchanges, and it's not nearly as clear that the semantics that we are trying to preserve here is really very well defined. So I think that would be a crucial step here, making sure that if we want to protect the case that is on the bottom of the slide, that we understand what that semantics actually is in the first place. That's one comment. The other comment is this, of course, is only part of the picture. The really interesting cases happen when the proxy or maybe even the broker actually also has a security association, which might enable it to provide some additional security services. So there are probably more pictures of this kind that are still waiting to be drawn.
Jim Schott. I think we actually understand the semantics of the lower diagram pretty well. I mean, it's store and forward. It's you know, exactly the same as what we do with email today. So I think the semantics of that are fairly well understood. So.
Okay, and the first question from Carsten here, and I agree with Jim. I think, but my answer would be, have a look at what we did on the last two scenarios, because we are doing publish subscribe in two ways. One, using the co-op semantics directly, where you have a server, sorry, a publisher being a server, and the fifth section where we're doing publish subscribe with two clients. And you will note that the security requirements coming out of this are very similar. So I'm not sure it does matter so much, but so that's my first comment. The second comment about missing scenarios, that's very much welcome here, and that's the purpose of this discussion. Which are the missing scenarios that we need to include in this draft? Okay, I'm running out of time, so let me just quickly step through. We have some methodology for doing this analysis, and I probably should skip that now, but I mean, it's a basic type of security threat analysis where you identify the assets, you set security objectives, and you which are relevant for a particular scenario. So we're looking at a number of scenarios I'll show you in the next slide, and given these scenarios and the security objectives, we listed all threats we could think about, and based on those threats we thought about mitigations, and then we defined security requirements to handle those threats. So that's basically the methodology used. And then the next slide is the scenarios. So these were the 5 scenarios we considered. We arranged them in how requests and responses are related to each other. So in the first example, first scenario, there is a relation between, sort of a one-to-one relation between request and response, which is important, for example, in if you are doing a get alarm status type of request, when you need to verify that the client needs to verify that the response coming from an alarm status resource is actually directly linked to the request and not another response. And there is a second scenario is looking at multiple responses originating or relating to the same request, which is, for example, if you do a secure parameter monitoring, that you need to verify that the parameter is actually is a response. You get the response to a certain request, and you have multiple responses. And then the third scenario is called multiple request one response, which is the caching scenario, when a single response might be used as a response to 2 different clients. The fourth scenario is the caching and observe setting, which you have multiple requests and multiple responses. So one request might lead to multiple responses, and one response might be used for multiple clients. And then the fifth scenario is the publish subscribe, which I don't have a picture for, but it's not very unlike that of number 4. So just a final remark here, and that concludes the presentation, the draft overview, and that is that co-op was not designed for end-to-end security. So some of these scenarios actually extend the applicability of co-op beyond its original scope. And that's important to note, that the solution to these requirements will be a solution which provides additional functionality. So I have then a discussion slide, but if you have any comments, you could maybe start.
I can go back one slide.
Okay.
Jim Schott. Do you believe that the scenarios that you covered in here would deal with the multicast, unicast cases too. So you end up with either a multicast request with a unicast response or a unicast request with a multicast response.
To be honest, we haven't thought about multicast at all. So need to think about that. Good question. So I mean that's yeah, that's basically, maybe I should just say the concluding remarks here. That's the second bullet here. What important settings are missing? Maybe that's one of them, and that's for the working group to provide feedback on. So just concluding here, what we see is that we actually need to do more work on scenarios 3 to 5. We think we are done with 1 to 2. Would be very good if you have any comments on that. And we plan to add the reverse proxy and the HTTP to CoAP proxy for the next version. But we haven't thought about, but in order to add more scenarios, we need to have sort of an understanding of those scenarios. Like for instance, what is the relevant scenario where there is an intermediary node which is also trusted or have a security association? What are those scenarios? Because we don't know that. And so the conclusions, there are no conclusions in the current document, but there are 2 conclusions on this slide. That's basically that we see that some of these scenarios are have contradicting requirements, which means that there is not one single solution. You need to have multiple solutions. On the other hand, some of the scenarios have very similar requirements. So it's not that you need one solution per scenario. So the current setting is that there are 5 scenarios, but there are only 2 sets of requirements, essentially. So what you would need to have is at least 2 solutions. And I should also say that there is a discussion, security discussion is continued on Friday, and we're going to talk about some candidate solutions on Friday. And finally, if you want to follow the progress of the draft or be involved, so let us know. There is a GitHub, Klaus, GitHub. You could see the latest version. We progressed it since version 0.0. Any more comments, questions? Okay, thanks a lot.
So I think it's really important. It's really important that you think about the security requirements that you actually have in different scenarios that involve proxies and or PubSub servers, and we capture those because we won't be able to design the security services in such a way that they cover them if we don't know about them. So there actually have been some messages on the mailing list before that gave some of these examples, but we probably have to dig them out and phrase them in such a way that can be used in the context of this document. So I think that's a very important piece of work that people should be doing based on the deployments that they are interested in.
Hi, this is Hannes. What I would like to see is not abstract boxes, but specific scenarios that people are working on it, interesting to deploy, because specifically those will give us some more insight what the real challenges are. On paper, everything looks great. It's easy to draft these. Just an episode from the OWASP working group when we thought that we work in an HTTP signing solution. There, the problems were not like on paper. That's very easy. You take a key, an algorithm, and then compute the signature or the MAC over a number of the fields, and everything is great. It turns out that when trying to implement that, the problems were all sorts of platforms that people used, in intermediaries who messed around with signatures, and so on and so on. And those were the real problems that prevented us from making any progress. And here, it almost seems that we're just guessing. Nobody has some real practical use cases. Just sounds good type of ideas.
and I think we need more than that.
So what sort of level of detail do you want for real world cases? Do you want an actual case or do you want a probable case? Because I can lay out some probable cases that I can probably describe pretty closely, but I don't actually work.
Yeah,
on it,
I don't want to hear about probable use. I want to hear what people are really working on. The probable use cases, there are many of them, and but it would be nice if there are some people who care about it that much that they spend all the time on this to explain what it really is.
So yeah, please take Hannes. I'd like to understand what you mean by are really working with this and understands the problem. People are working with DTLS, and that means that you trust the proxy. So the problem appears only when you have a compromise in the proxy. What do you mean by working with it?
So you have their specific proxy use cases, and there are some specific scenarios. So people do work with proxies and core proxies. Like, for example, we have a cloud-based service, and we of course proxy it to other web services. So in our scenario, typically there's co-op on one side, and then there's HTTP on the others, and people use browsers and mobile phones to access those. This is not the scenario I'm hearing, and it's a very different. So people want to have a very specific expectation there. This stuff doesn't seem to be applicable, but there may be some gateway cases. Gateway at home, I have some functionality at the home router, and now I want to use it. I don't see those people here in the room. I know I've spoken to those people. They don't care about this, but they have other problems. And so it would be nice to get some people in the room who work on those cases in the real world.
Can we use the use cases document that we published as part of this input to real world scenarios?
So when and of course we can, but I remember. No, I don't know where these use cases came from. Like some of it sounded like, oh, that could be a scenario. Like for example, when I worked briefly on smart metering in Germany, they've cooked up something. The BSI has created some standard there. Like it's not what I think in Germany should happen with smart metering. It's what they came up with. So regardless of what my opinion is, that's what they want to certify. And if that doesn't fit, then you are just sad. It may be different in different parts of the world, which I haven't been sort of involved with. Maybe, that's the type of feedback I would like to hear.
Arke Ränen, to comment on you, Hannes, when you were asking about the use cases. The ones in this document, they are abstract, that's true. But for example, the case where you have something in between that sees the message, if there's details terminated, and another, let's say, TLS to another endpoint, that should fit right on your use case, where you have a cloud service in between, co-op and DTLS on one side, HTTP to the browser on the other side. I think the whole considerations in this document should apply there, one-on-one.
They should, but in that specific case, what these guys also want to use, they do want to do big data analytics. That's their sort of that's what everyone in the community, in the industry tells them. That's why they shuffle it to the cloud infrastructure in the first place. So encrypting and protecting the messages there, this is actually really super helpful for them. It's a totally independent communication, and the data is actually that you get out from one side is very different from the data you suck in on the other side, because there's actually you need to generate the value add. So if you think of a sports app or some of this stuff, there's a lot of sensor readings that come in, but then you get one number out on the other side that's sort of supposed to show you all sorts of how good you are, and so on and so on. So maybe I just haven't spoken to the right people there, but
So I think it's good that you have a view here on getting some real input to this work. I think that what we do, the scenarios we look at, are relevant. I'm not sure if people are looking at it, and I think they should. And when it comes to the co-op to HTTP proxy, it's not necessarily also that there is a encoding conversion or this type of aggregation. There are these cases when it's just mapping co-op to HTTP. So you don't want the proxy to be able to store all the values or to be able to read all the values. So that type of scenario also exists. And in that case, that's exactly the type of setting we're addressing here.
I've also, in context of my review of the co-op to HTTP document, I've also asked the people I know of this, and they said, no, unfortunately, we don't implement this. And maybe there are others, but my overall overarching concern is the group that does too much of the sounds like a nice idea work and not so much like reaching out. Maybe it's great stuff in the future, but getting some stuff done first and things that people actually really do. So like step by step, piece by piece.
Could you give an example of the first step in that process? What are you missing?
I think we really have to cap this discussion now. We are already six minutes in the agenda item after the agenda item.
Let's take it offline.
Yeah, so we will have to move the resource directory discussion to Friday. And we have 14 minutes left, 13 minutes left for the CENIML discussion we have to have today because Colin isn't available on Friday. Now, I'm already warning you, we are not going to stop here at 7:10 sharp. So I think the working group chairs will go away when the last people have left the room. So, Ari. Yes? How many do you want?
That's gonna be it.
Ari?
Okay, so
Give me this one.
So I will be presenting the current status of CENIML and the key open issues there. And in Yokohama, we made a lot of good progress and we decided on the format we want to use. But after that, there was quite a bit of discussion on the mailing list. Some of the issues we may have overlooked when we were designing the new format. So the version I presented in Yokohama was 0.2 and now we're at 0.6. So obviously, a lot of interesting things have happened meanwhile. So the key issue that we are working on is the base values, and where are the base values in the CENIML pack, as we call it nowadays. So how it used to be in the version that we had nice consensus on Yokohama is that they can appear in any CENIML record, and we can use the merge patch format to update previous base values. So if you have, let's say, 10 different CENIML records in your whole pack, and there would be some values that apply the first 5, that would be in the first record as a base value, and then you would have a new base value in between, and then maybe that would apply for the remaining 5. The good thing about that approach is that it's pretty compact. You can nicely compress your big CENIML packs. However, the key issue a bunch of people had with that is that it requires you to process the CENIML records sequentially. So you have to go one by one and then know because these new base values apply here and these base values apply here. So that was the whole discussion about the streaming or required streaming functionality on the mailing list. So what we did, based on the discussion, try to simplify the rules, but still trying to keep the nice features that we had already in the current version. So the new proposal is that you would have base values only in the first record. And if you have multiple base values that you wanted to use the same compression that you had in the previous version, you would have to do multiple CENIML packs. So that used to be multiple CENIML documents or multiple CENIML representations in the old terminology. And if you have base values, you have them mixed with the data values in the first record. So it won't be just base values, but it can be base and the regular values. And then to tell apart for future base values and future values, the base values would always have a label starting with a B, And then of course, whatever new extensions that is not a base value would not have the B. And in the CBOR presentation, those would be negative values, negative labels for the, or tags for the base values and positive for the regular values. Here's an example how it looks like. But you may have the question, why the base record? Why don't we have the base record with only the base values? That's something we are actually going back and forth with the authors and also on the list quite some time, and there were a couple of different proposals on that. In the end, we kind of concluded that maybe the best way forward is to have a mixed. The rationale behind this being that quite often when you send SendMail, you have only one single record there. You see, send one measurement out, one by one. And if you would do that and you would still have what we call base record, that would always be empty in those cases. So you would be using extra few bytes every time, and it would look a bit silly. Also, another issue was that depending the kind of library you use and depending what kind of programming you use, variant type arrays could be problematic. So if the first SendMail record would be of special type only having base and the following would have different types of values, some libraries don't handle that well. So you wouldn't be able to use the fast path there. So as I said, this is the current design where we end up with first record base values including regular values and following records having just the values. So another question is the people who are mostly against the streaming functionality, I checked with a few of them and they seem to be now okay with this new way of doing it. So is there anyone who thinks this is a bad idea or has any other comments? Why should we do things otherwise? Okay, is Peter coming to mic? No? So I guess everyone is happy with this way forward. Okay, or no one has a slightly strong opinion. Okay, well, we'll be going forward with that, of course, as usual, confirm it on the mailing list, but that seems to be a reasonable way forward.
This slide is really funny because, of course, now I notice it completely disagrees with what you just said.
Oh, true. It has only base values.
Yes.
Okay, so this disregard the first record details. That was based on the old format, so it has only base values. But the key point on this slide is that there was also a request to add links on SendML. So the idea would be that you could add more metadata inline or for various kind of future extensions. Originally, in the previous version, we actually had the links defined in the SendML document itself. However, we didn't really have a good way of explaining the semantics of the links. It was just a placeholder there. So we figured out it's probably better that we keep the links functionality, but it's defined in the core links JSON draft, which actually explains the whole semantics of how you use the links. And our current proposal for how to express the links would be one of the base values, what we call BL. You can put there just a simple link, or if you need more structure, you would use the escape encoding from the core links JSON draft, and it would look something like that, which is not pretty, but should get the job done. But that discussion we can have the exact format of the links in a separate session. But that would be a way to accommodate for the need to have links in SendML. I wonder if Michael is on MeetCo, but because Michael was the one that really mostly was asking for this, and yeah, it seems to make a lot of sense. I don't see anyone going violently on the mic. Okay, any comments?
Hey, Alexander Pelov, Aclio. Just a short question about, you mentioned that it would be possible to use CBOR tags eventually to distinguish for the base values instead of using the B prefix.
Yes, so this is showing the JSON serialization. In CBOR, we have negative tags for base values and positive tags for values. So that will be the way to tell them apart.
They are not positive, they are unsigned.
Okay, unsigned.
Okay, so there is some kind of things that we could do more in when we deal with the CBOR encoding of SendML. I mean, or do you consider, do we focus a lot on JSON and then you say, okay, in CBOR there will be this kind of a mapping, or can we do much more than this in CBOR?
Well, we of course want to have the JSON and CBOR formats aligned, so you do have the same functionality there. But what you had in mind for extra CBOR?
Well, as we know, in Cool we've been doing quite a lot of things with CBOR, and we really get to appreciate all the things that are minor details compared to JSON, but really allow you to go much further away when compressing the information when you go when you do it with CBOR. And I don't know, maybe it's not the place to discuss here, but I really like the tag functionality. I really like the things that you could use numbers to identify things instead of names, instead of strings, and so forth. You know, and
yes.
Yeah.
So the tags we already have defined in the SendML spec. So we have for the all the labels that are defined in this draft, they also have CBOR tags. So that is already part of this draft. But of course, we'd like to keep the JSON representation and CBOR aligned. So if there would be some funky trick you can do with CBOR, not with JSON, probably it wouldn't be sensible to have it here. That would be my hunch.
Okay, thanks.
Okay, so if there's no further comments, then we'll go forward with this way of having the links extension. Then there was a comment from a security ADs on the use of long-term stable unique identifiers. So basically that it's a bad idea to use, for example, MAC addresses in this kind of context because they could be leaking privacy-sensitive information. How we address this in the latest version of SendML is that we have one comment telling exactly that, it's a bad idea, and referring to the RFC 7721, which discusses these issues for IPv6 addresses. But of course, a lot of that discussion applies also to other sort of addresses or stable identifiers. And just recently,
Colin here. I just wanted to add one more on the privacy sensitiveness. Some conversations happened this week with privacy people about that, and it may impact other things people are doing in here. Okay, originally we had MAC addresses that's sort of doubly bad and it's tied to network information. But other long-term stable identifiers that might be, loaded into your firmware and never change, obviously we need those for certain management reasons over periods of times. But what they think a best practice for us in general would be to have a way so that the administrator had a way, if they wanted to change that number, to cause it to be regenerated or updated to a new number. And not that would be done often. It certainly wouldn't be like every time the device rebooted or anything. That'd be useless for most of our use cases. But that type of idea. And that may not always be possible for us for some of our use cases, or it might be, but I think it's something worth thinking about in design of this stuff.
So just to continue the funny slide thing, this has a one-wire identifier on it, which you cannot change.
Yeah, I mean, and lots of our use cases that we're looking at, industrial cases, they want it so that the computer that's plugged into the one-wire sensor, if they unplug the computer to replace it and plug it back into the same sensor, it becomes the same device from a management point of view. It needs to have the identity of the sensor, not the identity of anything else or anything that's possibly changeable. So I think that's a great example of one that it doesn't make sense. Also, that's a factory floor. It doesn't actually, it's not personal identifying information. It doesn't have the same set of privacy concerns of a heart rate monitor. But a heart rate monitor might be one where maybe if you sold it to a different user, it would be good if it was somehow resettable so it no longer became tieable to your complete heart rate history. I don't think there's any right answer we can put in this draft. I think we can just discuss some of the issues that come up.
Hi, this is Hannes. Does it work now? I think the reason why this identifier and also the metadata about the units of measurement and some of these privacy discussions is because the document dates back to the time when it wasn't quite clear on how this would actually be used, in which scenarios. And it was sort of like, oh, I randomly send something out to some nodes that come along, versus, oh, I send it to nodes that I actually have nailed up connections, and so on. And so to answer that question, one would have actually to look at what the specific use case and deployments are where this is going to be used. Imagine a scenario where you have devices that send the data up to some cloud service. There you presumably may want to, as a cloud service provider who collects the data of a variable, you hopefully want to know like to what variable, to what user that is associated with. So there would be very different privacy consideration to the use of this in case of a sort of a beacon-like scenario where you send out whatever, temperature measurement or whatever. And I think without that, it's hard to say on whether one or the other identifier makes sense, what the privacy considerations are, and so on and so on. At least I would have difficulties to do that.
Yes, and as discussed earlier, hopefully there will be, I mean, CNML is not the right place, of course, to solve this issue, but we need to address the right documents that do actually discuss these issues, especially on the privacy side. But when it comes to do we need identifiers here and which cases, I mean, that's a very valid point, that maybe in some cases it's implicitly clear where is the value coming from. I think already in the current draft there is text, if you do a, let's say HTTP GET, you can use the URI you got it from as the base value. So it would be implicit there. But yeah, maybe we need a bit more thinking on that. Okay. And then there was a bunch of other late updates that we are in the current 06 version. So now there's a CDDL definition, so formal definition of the format of the data model. There's a registry for the labels, so you can go to IANA and ask for a new label if you want to extend CNML. New terminology, so we have CNML record and CNML pack that I've been using already. The long-term stable IDs, and we'll notice that the XML part is quite far from ready right now, so don't look at it too closely, but the idea is to keep it still there. Okay, that was all I had the slides for. We were only 4 minutes over time.
Okay, so just to have the draft name on the slide here. I think the obvious next step is to go for working group adoption. So my question would be, is anybody against adopting this as a working group draft now that we may? Or Charter allows us to do that since yesterday? Any opposing ideas? Anybody who would like to adopt this as a working group draft? Okay. So again, we will validate this on the mailing list. The second observation is this is probably then very close to a working group last call. So after adoption, there will be a draft IETF something, and we will do a quick check on the mailing list, but the next thing then probably would be doing a working group last call. So people like OMA can actually use that. And the third thing that we said was that we do we reverse an arrow. So instead of the CNML draft pointing to links JSON, we have links JSON pointing to this draft. There is a certain assumption here, which is that this draft can be processed quickly. The links JSON draft, again, is a dependency of the resource directory draft, which is another draft that we want to ship quickly. Yeah, how these arrows point is a little bit of a management issue, but the assumption is we can do it this way because this is non-controversial and we can get it through quickly. Just wanted to point that out once more. Anybody who cannot live with this pointer reversal? Okay. Then we are done with today and see you on Friday. Hello?